When solving these gas law problems with stoichiometry, I want to encourage you to use two words: patience and persistence. These problems are going to seem much more complex, even though you know how to do everything in this problem. You're going to say, that took forever, that took so much space on my paper, that was really hard. The thing that makes these problems hard is that you're not used to being patient and persistent in solving problems with multiple steps. So let's look at problem number 1 from gas stoichiometry worksheet 1. And so the first thing we're going to do is make sure we have identified what we are looking for at the end of this problem. Well, let's see here. It says, what volume? Oh, that was easy. That was so easy.
That was easy.
I need to get out my button. What volume in milliliters of carbon dioxide? Now let's find carbon dioxide here. Forms when 525 milligrams of calcium carbonate reacts with excess hydrochloric acid. So calcium carbonate is commonly used in antacids and combines with stomach acid, and that's going to produce some CO2, and so you're going to be burping after you take that antacid. And so I haven't checked for sure for a while to see if 525 milligrams of calcium carbonate is the amount in a tablet of something like Alka-Seltzer, but I am just willing to bet that that's the source of inspiration for this brilliant problem, whoever wrote this problem. So what we're looking for are the volume in milliliters. So that's going to be a volume of a gas, right? It's a gas. So to calculate that, we're probably going to end up using PV equals nRT and solving for volume. But before we can get volume of the CO2, we're going to have to do some things to get milligrams of calcium carbonate turned into moles of calcium carbonate. So let's look and see the other things that we know in this problem. The things we know are as follows. We know we have 525 milligrams. 525 milligrams of the calcium carbonate. But guess what? We have to convert that eventually to moles of calcium carbonate, right? Well, for now, let's just convert it to grams. So 1 gram of calcium carbonate is 1,000 milligrams. So the milligrams cancel, and we have 0.525 grams of calcium carbonate. That's how much of the limiting reactant we're starting with. It says there's excess hydrochloric acid. What else do we know? Well, we know something about the pressure at which this is occurring. 25 degrees Celsius. Now, of course, it's a gas law problem, so we have to add 273 to convert that to Kelvin, and so that's going to be something like 298 Kelvin. Wait, you see my mistake. I know, I got it here, got it covered. That's temperature, not pressure. Do we know something about the pressure? Well, the pressure is up here, 201 kilopascals, 201 kPa. And of course, we usually use a value for R that requires us to have that unit in atmospheres. And 1 atmosphere is equal to 101.325 kPa. So we need to convert that pressure to atmospheres. So 201 divided by 101.325 equals a little less than 2 atmospheres, 1.983. Notice I'm not going to round these intermediate steps. I'm going to worry about rounding my final answer to the right number of sig figs, but not these intermediate steps. And of course, the thing we're looking for is the volume of CO2 gas. That's the thing we're wanting to find. So we have several things we have to do here. And the first thing I'm going to do is stoichiometry to see if I start with 0.525 grams of calcium carbonate, how much CO2 will I make? So the first thing I'm going to want to do is balance this equation. So let's look up here and balance it. 1 calcium carbonate, and there's CO and an oxygen. I'm looking at this and going, I think the only thing I have to do to balance this is put a 2 here so that I have 2 hydrogens to go with these 2 hydrogens and 2 chlorines to go with these 2 chlorines. So the equation is balanced. So I'm going to do the stoichiometry right now. And remember, stoichiometry, we start with what is known, and we're going to move toward finding what is unknown. Of course, what we really know to get, what we need to know to get volume of CO2 is we need to have moles of CO2. And I want to put N CO2 because that's what we're going to have to do the stoichiometry to find. So let's just do the stoichiometry real quickly here, and I'm going to switch to a different colored pen for a moment to do the stoichiometry. I know I have 0.525 grams of calcium carbonate, and I'm going to convert that, grams of calcium carbonate, to moles of calcium carbonate, moles of my known compound. And I'm just going to use, to do that, I'm going to use the molar mass. I'm going to add up the mass of calcium and the mass of 1 carbon and the mass of 3 oxygens, and I'm going to get 100.09 grams. 100.09 grams of calcium carbonate. Now the next thing I need, of course, is this moles of CO2. Well, that's where I can use my mole ratio from my balanced chemical equation up here, and it's I'm looking for moles. Let me erase that for just a moment. If you already wrote it down in your notes, you don't need to erase it probably. We're looking at moles of CO2. That's our unknown. That's where we want our final answer to come out in, those units. And I want moles of calcium carbonate to cancel. So where do I get those numbers? From my balanced chemical equation. So this is going to cancel this. And how many moles of carbon dioxide are in my balanced chemical equation? 1. And how many moles of calcium carbonate? Get the right button. There it is. 1. So that's a 1-to-1 ratio. So I do my calculation here, and I get 0.00524, something like that, moles of carbon dioxide. Well, now I have moles of carbon dioxide that I can put into my PV equals nRT equation. So since I need to show my relationship, the law, the gas law that we're using for this, in other words, we're taking PV. I'm going to switch to a different color for just a moment. Come on, computer. And I'm going to switch maybe to this purple color. So my relationship that I need to use is PV equals nRT. And I should be able to solve that now and rearrange it to find my unknown, my volume of CO2 that I'm going to burp up. And so I'm going to rearrange this to get volume by itself. Volume equals nRT over P. And if you're needing some help with that, be sure and talk to me or get some help from someone about how to solve that simple bit of algebra there. Because if that's something that's confusing you in your background, we need to be sure we get that taken care of. Now we're going to do the substitution. We're going to substitute in N. Well, that's the number of moles we just calculated. 0.00524 moles. I'm going to include my units here. R is 0.0821 liters times atmospheres divided by moles and divided by Kelvin. Of course, these moles now cancel out. T, temperature. Where's my temperature? 298. 298 K. Of course, the K's are now going to cancel out, factor out. And then I have P on the bottom. Where's my P? There's my pressure. 1.983, 1.983. And that's ATM. And those probably better cancel out. And I'm going to get my volume in liters. And so my volume in liters, get my calculator out and put all of those numbers in. And I should get 0.0646. 0.0646 liters. But that's not my final answer, is it? Nope. My final answer needs to be in milliliters. So I need liters to cancel out and be replaced by milliliters. One big thing is a lot of little things. 1 liter is 1,000 milliliters. And so I need to multiply by 1,000. So this is going to become 64.6 milliliters. And now I've done something I really hate when students do, and I need to avoid this. But here's the thing I did that I don't like, and that's putting the answer in the middle of the problem. And I did that because I tried to work in 2 columns, and it just didn't work out. But there's the answer. You can do a better job on your paper. Thanks for staying with me through that. That is the kind of patience and persistence you need to solve these kind of problems.